Welcome to another lesson. In this lesson, we're looking at question number 3 that was tested in April 2023. And the question reads, using the information given below, determine the level of output necessary for each sector to produce a final demand of 500 for sector X1, 1,600 for sector X2, and 2,000 units for sector X3. You have been given this table. You have the output and the inputs. Now, this is the application of Markov and input-output analysis. We want to look at what you need to do here. First of all, you know that X is equals to A plus Y, which we know that X can also be identity matrix minus A inverse multiplied by Y. Here we have the sectors and we have the output. Sector X1, the output here we have is 40 plus 40 plus 40 plus 680. This gives me, when you add this is 800. This is 120, 800. X2, we have 40 plus 80 plus 80 plus 1,400. This gives me 1,600. X3, we have 400 plus 1,200 plus 280 plus 2120. When you add this, that is 400 plus 1,200 plus 280 plus 2120. This gives me 4,000. Having obtained this, is now us to get the technical coefficient matrix. Let's get the technical coefficient matrix. Now, with the technical coefficient matrix, we are going to have the users, and we are going to have the users, and then we are going to have, let's work it in a new page. I think the space here is not adequate enough. Let's come down here and look for technical coefficient matrix. Technical coefficient matrix. Here we shall have the users on this side, and here we shall have producers. Then we get X1, X2, and X3. And on this side, we also have X1, X2, and X3. These are users. Now, for you to get X1 means I take 40 divided by 800. You see the first column, you divide by 800. The second column, you divide by 1,600. The third column, you divide by 4,000. This is supposed to be 4,000. This one is 4,000. So, what do you get here? This is 40 divided by 800. Here you have 40 divided by 800. And here you have 400 divided by 800. Where am I getting them? They are here. 40, 40, 400. The first column. What is this? 40 divided by 800, 0.02. This is 0.02, and this is 0.5. The next one you divide by 1,600. 40, 80, 1,200. So this is 40 divided by 1,200, 1,600. Then here you have 80 divided by 1,600, 1,200 divided by 1,600. What do you get here? 0.025, 0.05, and this is 0.75. The third one, we have 40, 80, 280 divided by 4,000. So we shall have 40 over 4,000. Then we have 80 over 4,000. And then here you have 280 over 4,000. This gives 0.07. This gives 0.02. And this gives 0.01. So I can simplify my matrix here and say, I can easily say that my matrix, my technical coefficient matrix is 0.02, 0.02, 0.5, 0.025, 0.05, 0.75. This is 0.01, 0.02, 0.07. That is the technical coefficient matrix. So we want to find now I minus, therefore we need to find identity matrix minus my technical coefficient matrix. How do you get identity matrix? Identity matrix is this is the 3 by 3 matrix. 1 0 0 0 1 0 0 0 1. I minus what I have provided here. This is 0.02, 0.02, 0.5, 0.025, 0.05, 0.75, 0.01, 0.02, 0.07. When you subtract this, what do you get? 1 minus 0.02. Yes? What was, let me check here, wait a minute. What is 40 divided by 800? Sorry, this is not 0.02. This is 0.05. Here, 0.05. 400 divided by 800. This gives me 0.5. That's okay. 40 divided by 1600. This gives you, okay, that's all right. So what you are saying is here, this is supposed to be 5. This is 5, 5. When I subtract this, I'm going to find this is 0.95, negative 0.025, negative 0.01. This one I'm going to find is negative 0.05, 0.95, negative 0.02. Yes. Here I'm going to have negative 0.5, negative 0.75, and then here I'm going to get this is 0.9, 0.93. Now, remember what we need here. We need, if you want to find x, is I minus A inverse multiplied by y. So what I have here is I minus A. I want to find the inverse. How do I find the inverse here? The first thing is to find the minus. Get the minus. minus matrix. To find the minus matrix, you cancel the rows and columns touching 0.95. You'll be left with 0.95, then negative 0.02, then negative 0.75, 0.93. Where am I getting them? You cancel this one and you cancel this one. You're left with these 4. Next, you do the same. The second row, second column and first row, you cancel that. You'll get this is negative 0.05, negative 0.02, then you have negative 0.5, then you have 0.93. That, you cancel that, you get negative 0.05, negative 0.95, then you have negative 0.5, then you have negative 0.75. This is our minor matrix. This is our minor. We go to the second row. Our minor matrix here. Our minor matrix. We are going to have, this is negative 0.025, negative 0.01, then we have this negative 0.025, negative 0.01. Get this should be negative 0.93 positive. This is 0.93. Where am I getting this one? If you come here, you're in this row now. I cancel this one and I cancel this one. I'm left with these 2 and these 2. Good. Next, we have negative, not negative, I'll have 0.95, negative 0.01, I have negative 0.5, then next is 0.93, 0.93. Get the determinant. Here we have 0.95 minus 0.025, then minus 0.5 minus 0.75. Get the determinant. Here we shall have negative 0.025, negative 0.01. Here you have 0.95, 0.02. Get the determinant. Here we have 0.95 minus 0.01, then negative 0.05 minus 0.02. Get the determinant. Finally, we shall have 0.95 minus 0.025, then negative 0.05, 0.95. Get the determinant. So that's how we get the minor matrix. Here we are breaking, we are cancelling those rows like the first one. You cancel this row and this column. You cancel this row and this column. You are left with this minor matrix. Here you cancel this one and you cancel this one. You are left with the minor matrix. Here you cancel this one and you cancel this one. You are left with the minor matrix. I hope that is clear up that point. Now, after doing this, you need to find the determinant. I hope at this point you know how to find the determinant. How do you find the determinant? You multiply the diagonal matrices minus the other matrices. This one multiply this one minus this one. I done these ones, so when you do them correctly, you'll find that this is 0.8685. This is negative 0.0565. Then 0.5125. This is negative 0.03075. 0.875. 8.8785, and then negative 0.07, it's negative 0.725, 0.01, negative 0.0195, and 0.90125. What am I saying here? Let me pick the last one, for instance. This 0.95 times 0.95, that is the diagonal matrix. 0.95 times 0.95, that is the diagonal matrix, minus, into bracket, negative 0.05 times negative 0.025, close the bracket. You get 0.9025. So those are the what? Those are the determinants. So they give you the minor matrix. We need to get the cofactor matrix. Remember, all this you're going to follow this: plus, minus, plus, minus, plus, minus, plus, minus, plus. This one, where there is the first one is a plus, the second one minus, third one plus. So they are going to give us what we call the cofactor matrix. When you do this, you will get what we call the cofactor matrix. Therefore, if I bring these signs here, I'm going to have this matrix will change to 0.8685. Minus and minus will give me plus 0.0565. This is 0.5125. Then minus and minus give me plus 0.03075, plus 0.8785. Minus and minus give me 0.725. Then here 0.01. Minus and minus give me 0.0195, and finally 0.90125. Can we find the determinant? And we want to find the determinant. We want to find the determinant of this matrix, the A matrix. We want to find the determinant of the A matrix. Yeah. How do we find the determinant of the A matrix? Already we have been given the, if you come here, you shall have this matrix is one which A1 minus A matrix is what we are looking for the determinant. That is 0.95 times the cofactor matrix. That's what we are going to do. Then negative 0.25 times the value of the cofactor. Then we have negative 0.01 times this value here. So determinant will be 0.95 times 0.8685 plus negative 0.025 times 0.0565 plus negative 0.01 times 0.5125. Where am I getting these figures? Here. Negative 0.5 times this one, Then negative 0.025 times this one. Finally, negative 0.01 times this one. What do you get? The determinant, when you do it nicely here, you're going to find 0.8185375. So we are looking for the output. Our x is equals to 1 over the determinant, 0.8185375 times, you transpose to get an adjoint matrix. Transpose this cofactor matrix. The rows becomes the column. 0.8685, 0.0565, 0.5125, then 0.03075, 0.8785, 0.725, then 0.01, 0.0195, 0.90125. Then I multiply by the output. The output you have been given here is 500, then 1,600, and finally 2,000. Where am I getting these figures from? Here. Output is here. You have been told 500 units, 1,600, and 2,000. So what is X1? What is X2? I think up to this point you know how to get to multiply matrices. Let me show you how to get X1. X1 will be 1 over the determinant, 1,85375, times here 0.8685 times 500 plus 0.03075 times 1600 plus 0.01 times 2000. When you do it here, you get X1 as 615.06. X2 will be 1 over 0.818535 375 multiplied by 0.0565 times 500 plus 0.8785 times 1600 plus 0.0195 times 2000. You'll get your X2 is equals to 1799.37. Finally, X3 is 1 over 0.8185375 into 0.5125 times 500 plus 0.725 times 1600 times 1600 plus this is 0.90125 times 2000. When you do that, X3 will give you that 2.32. So that's how you're supposed to do this question. We move on to next part. You are told part B. The monthly rent paid by a resident of Hillsview Estate is found to normally distributed with a mean of 22,150 and standard deviation of 8,900. On the basis of sample of 200 residents, construct a 95% confidence interval for the monthly rent. So here you'll be told that the mean, here mean is 22,150, and standard deviation is 8,900. To construct the confidence interval, we know X bar, it is X bar plus or minus what? Plus or minus Z alpha over 2, then S over the square root of n. Here we already have the mean as 22,150. So X bar is 22,150 plus or minus 95% confidence. If you look at, when you're looking for the Z score at 95%, yeah, the Z score at 95% is supposed to be 1.96. Yeah, Z score at 95% is 1.96. You need to read from the Z table. Multiplied by S is the standard deviation, which is 8,900. Divide by the square root of 200. This will give you 22,150 plus or minus 1,233.477. So lower limit you subtract is 22,150 minus 1,233.477. What do you get here? When you subtract this one, you get 20,916.523. Upper limit you add. Upper limit is 22,150 plus 1,233.477. So this gives you 23,383.477. So the confidence interval here will be 20,916.522 is great. That means the mean should be greater or equals to, and it should be less or equals to 23,383.477. I think that is noted. When you come to test of hypothesis, you are told that test the hypothesis that the amount paid in monthly rent is 20,000 at 5% significance. So hypothesis testing. So we assume that H null is the same as the mean. H mean is equals to mean. And at the next we say that the hypothesis X mean is less than mu. So here we are talking about the first one being 20,000 should be equals to 22,150. And the same time you're saying that 20,000 is less than or equals to 22,150. So we want to test this hypothesis. So we have been given the significance, 5% significance level. Here we have 5% significance. 5% significance level. Therefore, it means our alpha is 0.05, which is 5%. First of all, get the Z score. The Z score is mean minus X bar minus mu divided by S divided by the square root of N. This means you have 20,000 minus 22,150 divided by 8,900 divided by square root of 200. So here, when you look for this Z, you realize that your Z is negative 3.416. But we were interested in the 5% significance level. Therefore, if you were to have your normal distribution here, our Z critical is supposed to be 95%, which is negative 95% is negative 1.64. But what are we getting? We are getting Z calculated is negative 3.416. So what do you conclude? We conclude that you reject null hypothesis, since Z calculated is less than Z critical. Since Z calculated is less than Z critical. Therefore, the monthly rent is 20,000. This means monthly rent is 20,000. That is it about the hypothesis testing. So our interest here was 95% significance. So you already, the Z score for 95% can be obtained from the Z table. Then you calculate your Z at 5% significance here, where we have this being our mean minus, we are assuming this one is less than 150. So when you take this one minus this, it is going to give you a Z calculation. So when you calculate this Z, you find that this Z is less than the Z which is in your mathematical table. Therefore, it means that you reject. That is wrong, because the Z itself is less than for that. It's not the correct one. So in such a case, that's how we test the hypothesis, and that's how you are to get your 20 marks in this question. Otherwise, we are going to stop there. We meet in our next video.